That'll be a key question today. And then also be able to, your learning target, simplify and evaluate expressions with negative and rational exponents. All right, so a few things that you need to know. What do you do with a negative exponent? Well, the first key here is anytime you have something to the negative first power, it is just kind of one of the general rules that we have in algebra is that you can't have a negative exponent in your final answer. So the hack to this is equivalent to 1 over x to the positive 1, or just 1 over x. This is the equivalent thing, and of course we have usually something more than just negative 1 here. We might even have a coefficient. So in general, if we have a times x to the negative b, so instead of a specific negative 1, but just any number in general, this is going to be the same thing as a over x to the positive b. All right, we also have a quotient rule. I think we've seen this actually kind of accidentally earlier this year, but you've definitely seen it in previous classes. Anytime you see x to the a divided by x to the b. So the key thing here is that you have the same base for your exponents. They're both x. This is going to be the same thing as x to the a minus b. And of course, if b is greater than a, then that means we're going to wind up with a negative exponent. So we're going to have to do this whole mess up here. All right, and then rational exponents, the big thing for today. I guess the biggest thing, I'll skip down to the last one here, and that's that if you have something like x to the m divided by n. So if you have just any kind of fraction up here, this is going to be the same thing, kind of applying the power rule backwards. This is going to be the same thing as 1 over n to the m power. The reason for this is simply because if I have an exponent to an exponent, well then I would multiply them, and 1 over n times m would get me back to m over n. So this is going to be very helpful. I'll give you a quick little example. If I had something like 49 to the 3/2. The way I would break this up is I would say, all right, this is 49 to the 1/2 power, and then I would take all of this to the third. And, well, 49 to the 1/2 power, remember that would be equivalent to the square root of 49, and the square root of 49 is 7. And so now I have 7 to the third power, and that's 249. Okay, so that's essentially how we take care of rational expressions. Now, here, this is kind of I guess they're not special cases. You got two cases when you've got these. You could have 1 over an odd, or you could have 1 over an even when you have these rational expressions. And so when you have something to the 1 over an even number, the thing that I want you to remember is that x must be positive. Okay, and so here's kind of the rationale. Let's work with just some simple examples. If I have 25 to the 1/2, okay, well this is 5, right? That's possible. It's positive and it works out. It's kind of like saying, what is the square root of 25? I could even have, well, here, let's do the counterexample. If I had the square root of negative 25 or negative 25 to the 1/2. Again, that would be like saying what's times itself equals negative 25, and the answer is, well, it doesn't exist. Nothing times itself equals negative 25. So that doesn't work. Now, you got to be careful here because we do have something that's essentially different. If I say negative 25 to the 1/2, this is a little bit misleading because it looks like negative 25 is negative. But in fact, 25 is still positive. This is the same thing. If we think of the order of operations, we would do exponents first. So we do positive 25 to the 1/2. But then we would do this negative, which is like saying negative 1 times positive 25 to the 1/2. Okay, in which case we would wind up with negative 5. Okay, so this winds up being okay. I know that's weird. You're just gonna have to deal with it. But the negative is when the negative is on the inside of the parentheses. We're truly taking negative 25 instead of 25 to the 1/2 and then negative 1 out in front. Now, when you have 1 over an, or sorry, this was all even, so I guess we'll switch these. When I have x to the 1 over an odd, okay, x can be positive or negative. And so I'll use my examples and counterexamples down here. But if you have x to an odd number, you could think, all right, well, hey, let's pick a good number here, like 125 to the 1/3. Okay, it's like saying what times itself 3 times would equal 125, or the cubed root. Well, of course, the answer is 5. But if I have negative 125, even inside the parentheses, to the 1/3 power, it's okay for this to happen because negative 5 times negative 5 is positive 25, and positive 25 times negative 5 is negative 125. We do get back to this number here, and so you can do a positive or a negative when you're working with 1 over an odd. All right, so we've got a number of examples here ranging in difficulty. This first one here, we've got lots of negative exponents, but the power rule with division here is going to come into play. We've got 15 divided by 25. Divide both those by 5, and we're going to get 3/5. If I take a to the negative 5th divided by a to the negative 2nd, remember that we're subtracting, but if I subtract negative, it's like adding. So this is going to be a to the negative 3rd. And then negative 1 minus 4 would be negative 5. Now we can't have negatives in my exponent. I know you could probably skip right to the shortcut if you knew what you're doing, but kind of the long drawn out explanation of how this works is a to the negative 3rd is going to be the same thing as a, or 1 over a to the positive 3rd. Similarly, this would be 1 over b to the positive 5th. And when I multiply these all back together, we wind up with 3 over 5a to the 3rd, b to the 5th. And so this, basically, you wind up putting the a to the positive 3rd on the bottom, b to the positive 5th on the bottom, and that's my final answer. But this is the reason why all that works. All right, here we've got an odd number in my rational exponent, my denominator, and so that means even if this is a negative number, that's okay. Remember kind of some of our power rules from earlier this unit. 8 to the 1/3, we'd have to take both the numerator and the denominator to the 1/3 power. And so, again, you're thinking, hey, what's the cubed root of 8? Well, that'd be 2, and the cubed root of 27 would be 3, and we got the negative sign out front, so that one winds up being pretty easy. I did want to throw one more on here. I don't think this one's in your toolkit, but it's a good one because this one doesn't have just a 1 in the numerator. It's got a 4. And so the way we're going to treat this is we're going to say it's negative 32 to the 1 negative, or I guess, sorry. We're going to turn this into a 1 over positive 4/5. Okay, so just kind of applying that rule that we did over here. So we've got a positive exponent now, and now we'll take care of that. So we've got 1 over negative 32, and we're going to say over the 1/5, but then we're going to take all of that to the 4th power. Okay, so first step, negative 32 to the 1/5. We have an odd denominator in our exponent, so that means it's okay that this is negative. We'll say, well, the fifth root, what times itself 5 times would give me negative 32? Can't be too many options. It's actually going to be negative 2. So we've got 1 over negative 2, and now we're taking negative 2 to the 4th power, and negative 2 to the 4th power is going to be 16. And that's how that one goes. So you can see here in this example how we kind of pulled out the 4. We took the 5th root of negative 32 and then got that to turn into 1/16. All right, so kind of increasing in some difficulty here. We've got x to the 3/4 and then divided by x to the 5/4 times x to the negative 2. The first thing I notice is that we've got x's for all of our bases, and that's kind of a reassuring thing because that means we all have the same base and we're going to be able to do a lot of things. All right, so my first step is I'm just going to clean this up and say, all right, this is x to the 3/4 divided by x to the 5/4. And I'm going to turn this into 1 over x to the positive 2. And at this point I have x to the 3/4 times 1 over x to the 2nd. And I'm going to rewrite all of this, x to the 3/4 divided by x to the 3/4 divided by x to the 2nd, but remember, if I'm going to subtract my exponents here, I'm subtracting fractions at this point, and so I'm going to go ahead and take x to the 2nd and turn that into 8/4. 8 divided by 4 would be 2, but now I have a common denominator, and 3 minus 8 would be negative 5. All right, so now I've got x to the 3/4 divided by x to the negative 5/4. And again, I have exponents with the same base, that's x, and then I also have just my exponents. If I'm subtracting them, well, then I've got the same denominator, and I need that before I subtract, and so we're going to go ahead and say x, and then 3 minus negative 5 would be like 3 plus 5, which is just oh, sorry. 3 minus 5, which is 3 minus negative 5 is 3 plus 5, which is 8. So I got 8 and then 4ths, and then put that together and I have x to the 2nd. So the whole thing winds up being x to the 2nd. All right, this one over here, it looks an awful lot like some of those that we've seen earlier. We're kind of doing the FOIL thing, but in this case, we've got rational exponents, and so we're just going to kind of stick with what we know. I think it will also be helpful. We'll talk about that in a second. So first, I've got 2z to the 1/2 times z to the 1/2. Remember, when I'm multiplying exponents with the same base, I'm adding them. And so coefficients, 2 times 1 is 2. And I've got the z. And then 1/2 plus 1/2 is 1. So z to the 1. Now I'm going to take 2z to the 1/2 times negative z. Now, over here, again, I have to add my exponents. And right now the exponent is a 1, which doesn't have a common denominator with 2. And so I'm going to turn this into 2 halves, which would be the same thing as 1. And now I've got the common denominator. So 2 times negative 1 would be negative 2. So negative 2z. And then 1/2 plus 2 halves would be 3 halves. So negative 2z to the 3 halves. Now I'm going to take this z again. I'm going to go ahead and make this exponent 2 halves, which means that I turn this into plus 1z to to the 3/2. And then finally, z to the 2/2 times z to the 2/2, or just z times negative z, would be minus z squared. All right, cleaning this up, combining my like terms, I'm going to have 2z. This was a half here. So because these have the same exponents and the same variable, they're like terms, I can combine them. This will be negative 2 plus 1 would be -1, so minus 1 z to the 3/2, and then minus z squared. Of course, we want to turn this into kind of standard form, and so we'll say negative z squared minus z to the 3/2 plus 2z. All right, and there we did a super version of FOIL. All right, I did change the last slide here to kind of make this a little more practical for what you're going to see in the exercises. So here, this is kind of another complex fraction, or at least it's going to be in a second. We have s to the -1 minus t to the -1. So my first thought is, well, let's get rid of these negative exponents. This is going to be 1 over s to the +1, or just 1 over s, minus 1 over t. And then over here in the denominator, we're just going to have 1 over s to the t. All right. Again, I know there's lots of tricks, but I'm just going to still go with, manually finding that common denominator. My least common denominator here is just going to be st. So I'm going to write that down, st, and then st. I think to myself, what did I multiply s by to get st? Well, that's t. So I got to multiply the numerator by that. And then what did I multiply this by to get st? Well, that would be s. So I have to multiply the numerator by s, and s times 1 is s. On the denominator, still working with 1 over st. Here at this point, let's combine our like terms. We've got t minus s over st. And then we'll kind of do the same change flip thing here, invert and multiply. We're keeping this the same. We're going to change the division to multiplication, and then we're going to convert this to st over 1. And, well, when I multiply these together, I kind of get these as my terms. And, of course, the 1 cancels out, but the st and the st up here also cancel out. I'm left with just t minus s, and that is what this whole thing works down to. So that's it for today. Enjoy.